Okay, so I think we're live. So let's see. Yes. Okay. So today is day 2 of the Advent of Code adventure. Let's go on and solve the second day. But first, let's start from where we left off yesterday and fix our scaffolding code. So this is our scaffolding code. It's not that much. I finally got Rust Analyzer to work by reopening the project so we can see the errors. For example, unused imports, and we can see the output types. Also, I will be talking a bit less than yesterday because I talked much. I didn't concentrate enough for the challenge ahead. So let's fix this scaffolding code by at least removing these unwraps here. So we can just match the errors and show some nice Christmassy errors. For example, here we can either match this one, we either get an OK with the result. The result is the content is a string, so we can return the content. Otherwise, we get an error. We can do this. Print a line. Couldn't read file. Maybe we can put like a reindeer here. I don't know. How do I check for a reindeer? No. Characters. Let's see if we have a reindeer. No. Christmas. Well, these will be used a lot. So let's copy the Christmas tree from the characters app and use that. So we couldn't find the template file and we just error. Process. Same thing is even worse. Now, as for the day, we can give an error for the day. So maybe even before getting the template, we can check that this is a number. So we either match the OK, or we get the error. We panic. We can panic. We can just and exit like this. Same thing for here. Must be enough. Now we replace the day inside the template. We format the paths and we try to write them. So let's try to put this into a nice function because I want to do the same thing as we did here, but for the file writing. So we either match an OK and do nothing. So let me try to do this. So, oh yeah, okay. So this we just do nothing. Otherwise, we can do the same thing. Like saying error while file, and we put the path here. Binary path, and we exit. Now, as for this, we can also try to extract into function. For example, write file save and use that for the other files. For example file path with the empty string. No, this was not empty. Let's try again. What was here? Yeah, it was an empty string. We can write to file save the example file path with an empty content. Why don't you like that? Expected a string, so let's do into. Let's create a string from that. Same thing for the output. No, the output, the input file is another thing. We just use this command, but we also want to get the result. So instead of printing this, we just match the result and then again fill the arms. If it's okay, then we print line. Successfully downloaded inputs for the inputs. Otherwise, same thing as before. We could print the error, but I don't want to do that, to do it right now. So error while writing the input file. And here is the input file path. And we exit. Now let's try to scaffold it. So I also want to try something else. So I could do it like this. So cargo run bin scaffold and then pass the day 02. But I want to create an alias for cargo. So let's do that with cargo configuration. So I go to alias. I can do this. That's nice. I can create aliases into the TOML file. Let's go to the cargo file and add aliases. Is it alias or alias? So if I want to solve a challenge, I can just do cargo run bin and name. We'll try later. If I want to scaffold, I can just do run binary scaffold and then pass the arguments. Here I just want to run the binary for the day. So let's try to solve. Cargo solve 01. Okay, there's no command. How do you do it? Oh, yes. Okay. The value may be in array of strings. Okay. Okay. So I also have to say run. Okay, I said run. Maybe maybe I just got it wrong. Cargo scaffold 01. No command scaffold. Find the right directory, yes. Let's see why it's not working. Oh, this was another. Oh, this is in the .cargo config, but it's from 2021, and I think this changed. Configuration again. This is the configuration files. Okay. Okay, so I need to write a cargo config. Okay, this here. So let's create a directory cargo and config toml. Now let's copy these two commands here and put them into the cargo config and try again. So if I do cargo list, I don't get the aliases, or do I? Let's see. Doesn't seem so. So there's no, oh, there's a solve, okay, and there should be a scaffold, okay. So if I try to do cargo solve for day 1, it runs, okay. If I do a scaffold for day 2, remember to put the 2 like this, it created the 02, okay. It created it downloaded the inputs and it created the example. Okay, so we are ready for day 2. Let's go. I also like to okay, like this. So scaffold, it's okay. Now the template has some errors. You can see them here. It doesn't have iter, it doesn't have m, it doesn't have on string. So let's delete them and fix the file. So the template is okay. What did I change in the first day? Nothing. Let's just remove some new stuff. And okay, so short date scaffolding and cargo conf. Now let's start with day 2. Okay, so let's close the other files. Let's close everything, and let's go to day number 2 and read the actual challenge. So on day 1, we finally found some locations based on the lists. Now it's time to read the report. So the location, oh, we need to start looking for the historian. Okay. Well, the red noses reindeer nuclear, what is this? The red noses reindeer nuclear fusion fission plant appears to contain no sign. Okay. Okay, so we are in a fusion plant. Oh, from 2015. Okay. So this is the fission plant for Rudolph. I mean, needs to get a lot of power to fly like that. We have no sign of the chief historian, but there are some engineers, and they are still talking about the time Rudolph was saved through synthesis. Oh, come on. It was incorrect. Okay, they are quick about that. They appreciate your help with some unusual data from the reactor. My turn to check if they are waiting for me. Mother currently searching every corner. So basically, on this advent of code, we are gonna follow these historians, looking for the chief historian and doing stuff like searching for errors. They're basically beta testers of the various locations. So the initial data consists of many reports, 1 per line. Each report is a list of numbers called levels. Okay, so this is an example. So this is the example, actually. Let's copy that onto the file. 02. This contains 6 reports, 1 for each line. Okay, the engineer tries to figure out which reports are safe. The red-nosed reactor can only tolerate levels that are increasing or decreasing, so a report counts as safe if both of the following conditions are true. The levels are either all increasing or decreasing, and any 2 adjacent levels differ by at least 1 and at most 3. Okay, so we need to check if every report, every line of the file is safe. In this example, we need to count how many reports are safe. Okay, so let's start from this. So given a line, we want to know if it's safe or not. So let's start from the examples and create some smaller tests. Now I'm gonna use RSTest, I think. This is a library I know. I read about. So we can write some data-driven tests, or at least some cases like this. So let's install RSTest. Okay. Now I wanna write the first test, which is for safe line. Let's call it safe line test. So fn safe report. Okay. In our safe report, we're going to get a string, which is the report, and a string and a boolean, which is if it's safe or not. Okay. What are our cases? Let's start from the first one. The first case is the first line of the example file. So this is our report. And this is, let's try. So they are all decreasing and their distance is less than 3 and more than 0. So let's go back here. This is safe. Okay. So this is safe. Now, do we want to follow a TDD style or not? That's the nice thing. So let's start with the TDD one. So we need a function called is safe for the report. So it gets the report, it returns something, and we assert that it's either safe or not. This is our test. Now, it doesn't work because I'm not following the... Okay, now import RS test, save again, and let me just pause for a bit. So should match the parameters list. Okay, the parameters list is a string and a boolean. Why is it not working? Because we need, oh, maybe because we want a string. Oh. Okay. I do into. Okay, it doesn't like this. That's fine. But why? Maybe I forgot to write something. Do we have examples with list? Yes. Oh, so we need to tell RSTest that this is a parameter for the case. So like this case. And now it's complaining because it wants strings. Now it is okay. Now another thing to do is to create the function is safe. So let's do it here. Let's do it near the test so we can see both. So the function is safe. We get a report, which is a string, and we return boolean. Now let's make it fail, and let's test just the binary open, otherwise we're going to be in much pain. Okay, it failed because we wanted a true, it's a false. Let's make it pass. Easy, easy. Okay. Next, we want to make it fail. So let's get the second one. Why should it fail? It fails because there's too much distance between the elements. So let's start with that. We want to test this case. Now, we want this to fail. And it's not failing. Oh, why? I could just check the first number, check the length, check the order. Let's check the distance between them. So we can do, let's try parsing the numbers. So numbers are the report split by space. This is an, let's try with map. We want to map every number. It must be, I mean, it should be unsigned numbers. Okay, let's try with unsigned and If we get any error, then we will know. Let's try to parse. No, it's n.parse. We don't care. And we collect it into a vector of u32. Does it work? No. It wants to know the type. So we parse as u32. And this number must be a vector of u32. Should work. Okay, now we have the numbers. We can check if the distance between any number and the next is at least 1 and at most 3. So let's start with that, because this case it is like this. So we can start from the first. Let's do it with a for loop, then we will do better. So forgot how to do loops. Just for and range. So okay, this is even better. We can go for I in 0 to the length of the numbers. What happened here? I don't know. Numbers length. Then we can check the next. So we have to go to number len minus 1. Otherwise, we will be in great pain. Now the difference is numbers of I minus numbers of I plus 1. And we can get the absolute. Was it? No. How was it? I just used it yesterday, but I forgot. Numeric markups. It's not the one I want. Tabs in num. So I just do tabs. No. Tabs. Okay, this is not an iterator. It must do. I just forgot how to do iterators. So it's like this. And this absolute value we don't have, because numbers must be integers, not unsigned integers. Always forgot about that. Okay, now the difference. If the difference is less than 1, or the difference is more than 3, we return false. Otherwise, we return true. Let's try. And this works. This was the second case. Now, this should be the same as before. No. Yes, because they are. Oh, so it's not safe because they are too far away. So if you see here, the 9, 7, and 6 are fine, but 6 with 2 has too much space with it, so should work fine. Let's go to another case, which is 1, 3, 2, 4, 5. Now, all of these have a perfect less than 3 difference, but they're not in order. So we want this to return false, but it will probably return true. And this is a failing test. We can work on that. Perfect. How can we check that the numbers are ordered? We could check the difference. So if we store the last difference, we can store all the differences. Yes. We can store all the differences and check that they are ordered, or we can sort it and check it, I think. We can do something like this. We can store the differences. So this is a vector of integers again. This is a vector of integers. Now, we can just append the difference here without the absolute number. Okay, let's do this again. So this is a difference. We can store the diffs here. And in the end, we can check that all of them have the same sign. How can we do that? We can yes, we can divide them by the absolute value of themselves. So like this. This gives us either 1 or -1, and we can check that diffs are all positive or all negative. So if all of them are positive, it's increasing. It's actually this D is a reference. Okay, so we do like this. Same thing if the difference is always less than 0. So they are decreasing. Now, if they are increasing or decreasing, then we're fine. This, why is it not working? Okay, expected. Oh, so the append doesn't work like this, but we can do add. No, how can I add something to a vector? This is a vector. We append. No. Okay. Vector is of size numbers length -1, and it's all filled with zeros. Is it like this? No. Okay, it's the wrong way around. So we need to get the number of zeros like this, and then we do diff of I equal to the one we just copied. So is diff divided by itself. Now, increasing or decreasing. If it is either one of these, we are fine. If it's not increasing or decreasing, either we have a difference of 0, so we have equal numbers, or the differences are of a different sign, and then it's not ordered. Should work? No, it doesn't. Okay. Which case? The last one. Perfect. Why? So, in this case, 1, 3, 2, 4, 5. Okay. 1. We should try to print all of this. We can try to debug the diffs to see what happens. And we debug the reference to it. So in this case, the difference is always 1. But why? This is the last case, right? Test case 5. Yes. We have 4 differences and they're all 1. Well, this is not right. Let's try to debug each single difference. Let's debug the diff and the diffs of I. Oh, because it's divided by itself. Oh, so we need to check about zeros, because if difference is 0, then we can add another. This case later. So diff is 2, we got diff 1, diff is 1, diff is 2, diff is 1. Okay. That's because diff is in absolute numbers. Okay. So this is the error. We need to make two differences. The difference not in absolute values, which is just the difference. And then we need the absolute value. So diff.abs. Now we can unify this. Should work like this, because we need the absolute value to check the distance. So this is actually the distance. We can refactor that like this. This is the difference, this is the distance. And then we can check again. Everything is working. Now, we didn't put a test in here. Let's try with the other test. It should work. No, now it shouldn't work because we have two fours. So we have a case in which it should fail badly. You don't panic. We have a division by 0 here. Instead, it is working well. That was not expected, but it's okay. No, this distance should be 0, so it shouldn't work. I mean, it's okay. We don't care. This should be safe. This should work. Let's do this and say that is working. Okay, so all our test cases for the safe method are passing. Let's apply it to the part 1. So part 1 is already reading from the examples. So we expect this to be something like 2. So we need a sum of 2. Let's see. Okay, so it's not working. Now, how do we do that? We split into lines. Then for each line, we just call our isSafe method. And we filter for safeness. We just use order safe, we count, and we return the sum. We return as a U32. Okay. Not expecting, it's not working. I did this. I need to use references better. This is not about, this is line. So if it compiles, it works. Nice. And we can also solve it. So if we go into cargo solve.202, 432. I hope it's the right one. It is the right one. Yay. Let's go to part 2. Now, the engineers are surprised by the low number of safe reports. Well, how many lines were there? The input. Well, we had 432, which is less than half the reports we got. Now, the problem dampener is a reactor module that lets the reactor safety system tolerate a single bad level in what would be a safe report. It is like the bad level never happened, so the same rules apply, except if removing a single level from an unsafe report will make it safe, the report instead counts as safe. Okay, so if we remove a number from the report, okay, we need to check that the report is safe when we remove a number. So we need to get the... Okay, it's fine. We can check it. So let's try the isSafe part 2 on these reports. I will create a new one. Maybe we can refactor it later. So we have a new test. Safe report with problem dampener. Is it the name? Problem dampener. With dampener, it's fine. Now we get that just 2 cases. Okay, this is safe. This is safe. Let's do it 1 case at a time. Now, if something is safe, then it works. if it was already working, then it will work. Let's test again. This works. Now let's start with one of these. We want this, which wouldn't run, to run and get true. And we run the is safe with dampener. We need to create the method is safe with dampener. Now, as you can see, I'm not refactoring this. It works. We like it. I don't know if it's efficient, but it's working. There should be a more elegant way to do it in Rust, but I don't care right now. So let's just, it's just doing 3 iterations over the array, so it's fine. Now, what about the dampener? The code is the same, and we can see that it doesn't work. It fails on the 11th test, which is this one. We need to remove one of the differences. So instead of saving the, we can save the distance too, or we can save the pair of distance and sign. So okay, we need to change this type. Instead of a diff, we have an I32, which is the difference. Or we can do it better. Instead of save, we could also not save this. So we don't need to save the sign of it. We can just save the difference. And we can check it is more than 0, less than 0. Now, we don't need this. We need to change that. So let's do a refactoring. No, we cannot do a refactor unless we pass the tests. So we don't need to stop at the first one. We just need to save the differences. So this is the differences. All distances, okay. We need to remove just one. Okay. We should check. No, it doesn't work like that. I mean, I wanted just to remove one number, but I think I will have to remove all the numbers one by one and rerun. No, so the safest method is to just run the is safe, modifying the report every time. So we can try that. Let's start from the beginning and do something else. Let's refactor first the is safe. We can stop doing that. Like this. So let's go back to the is safe method. Now this will not work. I don't need this for now. Okay, let's go back to our safe code and refactor it a little bit. So we don't need this. We just need to save the difference. Should still work. Okay. We can extract this and return the differences in numbers. So we can extract this and call it compute bits. No, I don't know what is this. Oh, because we have results. Okay. Okay, let's do it better. So we can check this by distances. Okay. We say diffs are all. Now this is a distance dot amps. So let's map it and just check the distances. So we have a distance. We get the absolute value of the distance, and we want all of these absolute values to be less than, more than 1, and less or equal than 3. We want these distances to be okay and to be either all increasing or all decreasing. Does it work? Yes. So we can remove this if here, and we can test again and see that it passes. We can also remove this, and again, all tests are green. This is our differences method. So we can extract this, extract into a function, which is compute this. And now it's way better. Okay, this is the function is safe. Okay, given a report. Let's transform it. So is safe string, because it also does the split, and we need this is safe function. So extract function is safe for the vector. So this is safe string is just used for the tests. I also want to extract this, but it's okay. We can do that. So I can extract. Let's call it extract the numbers. And now is safe string is just this. We don't need that for our. We can do that, or we can also do that in line into the resolution. So we can do let numbers, and then we call it is safe on the numbers. For each one, okay. Yes. Maybe it's better to just do this and inline. So we can do this thing and remove this function, which we don't need. Also, the main can go up there. We don't need it here. Fine. We have part 1, we have part 2. Then let's check everything is working. Okay. Why is it working? Because we inlined it. Is safe string is still there. Where is it? It didn't save. It shouldn't work. Okay. Numbers from the report. I prefer to separate the string handling and the splitting with the actual domain, which is checking if the report is safe, so that we can get a report from the numbers. Also, report can be unused variable, could not compile. Okay, so we have an error. Perfect. We have an error here. Again, this report is equal to extract numbers of report. This type is not needed. And this is a line. And this is working. Okay. This is the is safe method. Let's create the is safe with a nice loop with the dampener. Now we have some numbers, which is the rec of I32. We get a boolean. And for now we return false, so that it fails all the tests. Now we can comment this test. Most of them is a safe dampener. We pass it a list of numbers, which is our report. Now, to make all other tests pass, we can just return is safe of numbers. This should make most of the tests work. So the old test should work. The new test is failing. Let's try to not fail this test. Now, what we can try to do is to remove one number at a time and see which one is out. Or we can first get all the numbers which are not okay and check that just one number is not okay. But how can we check that the others are okay? So, okay. Let's start with the first one. 9762. Oh, we can start with easier examples, maybe. For example, this example here is not fine, is never fine. It will never be, I think. Exactly, so it should return false actually. So it's not a good test. Let's start with a nice test, like 1, 3, 3, 2, 4, and 5. Because we can remove the 3. Again, it fails, but it shouldn't. How can we make it safe? We need to remove the only one which is not right. But what if we remove the 3? I mean, we can remove the 3 because it is out of order. And that's fine. So we can do it by, let's inline the isSafe method so that we can check it. So this is the diffs, these are the distances. Let's remove these distances. I mean, maybe we can do that. Okay, let's first get the instances and then check if they are okay. I mean, distances are okay. I mean, for the ordering is fine. For the distances is not so easy. We should check a window over the array to test it. So if we get a window of 3 numbers and we can remove and just one of these windows is not safe, so it's not increasing, it's not in order, and okay, so we have a window to do. That's nice. Maybe. Okay. I think we need to work with windows here. Because if I have these numbers, if I have 1, 2, 1, 3, 2, 4, 5. Let's make some comments here. So if I get all the windows, I can get, we start from here, we have 5 numbers, 5 windows. The first one is 1, 3, 2. And this is not right. The second is 3, 2, 4. That's not windows. I mean, yes, it is Windows. We need to check the beginning and the end of the window. Because here we have 3 windows, for example. I mean, there's also 4 and 5. 4 and 5. There's also 1, 3. Now, what happens if I... Now, 1, 3 is okay. The difference is fine. I mean, first we check if everything is safe. So we don't even need this one. And these ones. I can just remove one of them. I think. If I have this, I can just remove the 3 and this will be fine. If I remove the 2, these are fine. No, it doesn't work like this. I mean, it's not so easy. I can just try to remove something and check if it's safe. I mean, let's go with a brute force approach. This is unused code. Let's go with the brute force approach and just do that. So if I have some numbers, I can start by doing this. If is safe, then return. And this is the base. Now, I remove one of each number. How to do that? Index for I in 0.numbersLen. I can do numbers dot what is the splice? Remove one element from vector. Yes. So I can try to do let remove. We've removed numbers. We have numbers position. Now, when the position is different, the position is different from the I, and then we collect it. And we just want one of these. If just one of these is safe, then it's okay. So we can also do this. I to 0numbersLen dot map. This is the I we need. We also don't need this. We don't need the 4. We can do a nice Pythonic stuff or Rusty stuff. So I is the position. We can close it here. We return is safe. We want just one of them to not be safe. So we want this to be equal to 1. Non è the name position. That's fine because we want the iterator. And the collect doesn't work. This is option. Oh, okay. Returns an option. Oh, so okay. Oh, we can just remove the index. Why did I do that? Okay, remove this the clone of numbers. It is mutable, and we remove at index I. Now Mm-hmm. How can I clone a vector? Back. Okay, that's fine. Why don't I search more often? Can do it on a reference so that I mismatched. That's fine. This is so maybe this will work better. Numbers then. Then. Come on. What? Borrow or muted? Okay, let's just on the lamp. What? Oh, this is just a new size. Why is it an issue? Okay. Needs an item. It needs a new size. Oh, okay, we need to borrow. Let's try to borrow. Okay. Now, if we are borrowing everything, then it's gonna be a mess. Everything we want to have borrowed data. We can work with that. Okay, we don't even need the use size here. Numbers to vec, number remove is safe of remove. We just need to have one number removed. If it's different, if it's 0, then it's okay. If it's 0, it's okay. Okay, it doesn't work. Why? Because is safe dampener and is safe also. They want a reference. That's fine for our tests. Now, again, line 24. We need a reference. It's still failing. Perfect. Why? Because I'm not calling is safe dampener, maybe. I am calling is safe dampener. Okay. It will be equal to 1. Still failing for test case 2. Why? Let's try to debug this. So we can debug we can try to debug this. Let's say and return difference of safe. Now let's debug the removed and let's debug safe. Why is it not working? Oh, because I need to put some exclamation mark, and now we have some removed stuff. So if we go with this, it's not safe. This is safe. Oh, if it is safe. No, wait. We need to have at least one. So if I remove one number, we need any, basically. We need at least one removal that is safe. we need to have, basically we don't even need this, we need the first one, which is safe, right? Why is it not working? We expected a boolean, and okay, now they pass, that's fine. So let's see again the examples of this. So we have two unsafes, so let's copy the other test cases. Again, we just need to modify them accordingly. This is true, this is true. Okay, it's waiting for the fourth case. Okay, this one. There should be just one safe. I have too many examples. Yeah. Waiting for the one I copied badly. Okay, let's compute part 2. So we need is save with the dampener, and we need to have a number which is 4 in our example. We test, and we solve 488. It's not that high. That's right. Okay. Now let's go back to our problem, because I mean we got the fourth star, but I don't like this algorithm at all. So let's check this. I mean, when brute force is not nice, and this code is quite ugly. Okay, we have our tests, we have our example, that's fine. We just need to not go with this algorithm. So these two are okay. This one is fine. These two are not. Now let's start from an example. The one we did before. One removal must be fine. So everything else equal. How can we not check in a Coven squared like we are doing? I just need to do it in one pass. Let me see, how much time have we been live? 1 hour and more. Nice. I mean, it's enough for today, but this doesn't sound right. This doesn't sound right. I mean, we could try to see if every number is increasing and just one isn't, then it's fine. If every number is increasing and just one is and decreasing and one is not, then it's okay. But what about the difference? Because we need to check the difference with the ones around. So we need to check on the one before and the one after. Right? If we remove the first number, then these will always be fine. It's okay. Let's start from the example. So let's go here and create a nice big funky comment. We have this. We have the differences, which are, in the first case, we have 1 and 3, the difference is 2. Then the difference is 3 minus 2. The first is 1 minus 3 is minus 2. The second difference is 3 minus 2 is 1. Then we have 2 and 4, which is minus 2. Then we have the 4 and 5, which is minus 1. we don't like the order. Let's make these, let's make it, let's see some examples. This is one. This is the second one we can convert. No. This is one we can, no, this is one which is fine. How can it be fine? It's between 1 and 3. What about one that doesn't work out? I mean, this is decreasing, but every time the distance is too much. So the first distance is 2. Then we have a 1, then we have a 4, and then we have a 1. So how can this be a false? Because no matter what we remove, the distances will be too much. If we remove, these are 2, 4, 1, okay. We need to sum the differences between numbers. So if we, for example, remove the 9, we still have a 4. We need to remove only one distance and check the surrounding ones. So if I remove the 6, which is the one causing, or the 2, if I remove the 2, then we need to get these two together and this becomes 5, which is too much. If I remove the 6, then I'm removing the one between 7 and 2, and it is again 4 plus 1. It's on the left. So if we have just one distance which is not correct, and if we remove it and sum the numbers on the right and left, we should get our new distance, right? But how does it work if they have different signs? For example, the one on the upper side. For example, if we remove 3, so we remove the distance of -2, it becomes 1, right? Wait. I think this might be way easier than what I want to. So this is the difference between 9 and 1, right? This is 4 plus 2, 6 plus 2, 8. Okay, I think I got it. Maybe. No, I don't know. Yeah. Maybe let's do it. Hmm. Always have difficult times with these kind of problems. I think this problem also has a name, but I forgot it. So it's like the sequence. No, it's not longest sequence. It's something like that. Yes, I need to get the only one which is. I mean, if the distance is too much, then it will always be too much, right? because if it's not the first one, at least. So if I remove, for example, if it's this one, then it's not because of the distance. I need to check the distance between the others, but it's because of the sign. Right? So I need to get the only one which has the sign different from the others, and then check the surroundings. But what if it's, for example, like this? This would work. I mean, we can try with a test case, but this would work. Do this. This should come out as true. Yes. Because we can remove the 1. If I try with, for example, 6, 3, 6 minus 3, it should be a false. If I try with minus 6, it should be a false again because it's too much. If this becomes a 6, then it should be a true. And again, I'm getting nice result. Let's try with these examples. How are the distances in these cases? We have a 2, we have a 1, we have a 9, and I mean 6 minus 1, okay, and minus 3 minus 1 is minus 4. This is again 2, no, this is 3, minus 12, no, 6, plus 6 is 12. We have a minus 6 plus 3. Minus 6 minus 6, which is minus 9, and 3 minus 1, which is 2. Okay. By removing the minus 6, we are basically putting together the 12 and the minus 9, right? Same thing for the 6 and minus 3. If we remove the minus 3, then we're putting together a 9 and the minus 4. We're summing them. This is a 5, and this is not okay. We're putting together the 3, the 12 and minus 9. This is 3, and this is fine. Okay, starting to get somewhere. We need to compute the difference between them, maybe. So if we go back to this one, we can compute the sum of these differences. So it's 2 plus 1 is 3. 1 plus 9 is 1 plus 9 is 10. 9 minus 4 is 5. And I said this is KO still. Right? Again, if I try to see 3 plus 12 is 15. Don't like that. 12 minus 9 is 3, and minus 9 plus 1 is 10. Still not enough. Maybe it's the difference which is important. maybe is the difference. For example, I mean, this works. I don't like it. I think I will stop the live here and take some time to solve it, and we will see tomorrow. So we will see tomorrow on day 3. See you.